Hello everybody, my name's Lucas and I'm going to be showing you guys how risky it is to cross the road without looking both ways before doing so. We've been told our entire lives that we should look both ways and it's for our benefit to look both ways, and recently I've been thinking that's a waste of my time, so I'm going to do some calculations and try to prove either that statement wrong or right. I'm not sure. I really just want to know if it's worth it to cross the road without looking both ways. So if I'm going to be making this life-changing decision and maybe deciding not to look both ways before crossing the road in the morning, I need to have some data to back up this life-changing decision. So what I did was on a Monday morning at 8 a.m., I went into my living room and looked outside the front window and started counting cars for about 3 minutes, and that's pretty much as long as I could take it before I realized it's way too early to be doing this. So what I did instead was I set up my camera and recorded the road for about an hour and then counted the cars that passed my house at like 4 times speed just to save me some sanity, and then I just went back to bed. Okay, so now that we know what data we're dealing with and how we collected it, we're going to now move on to the assumptions. And this is the process where we take a nice, sophisticated, complex, unique problem and dumb it down into something that some might call an insult to the scientific community. And we're just doing this to make my life and the calculations way easier than they have to be and save us some time. So it's a little boring, but if you sit through this, you'll get a better understanding of what the calculations I did mean and why they work. So first, you saw in the data collection portion that I only sat outside my house I only set up the camera for about an hour on a Monday at 8 a.m. And this is the rush hour in my city, and it's where the most cars come by, and my road is definitely way busier than other roads. So I said that, well, if we're just going to take the worst case scenario, this would be a good starting point, because I don't think it would be necessary to collect data on different days, because assuming most people work a Monday to Friday job and they leave work at the same time, and a lot of people leave at 8 a.m., I could have maybe set up recordings at different times, but since I leave for school around 8, this is what fits for my application, and that's really, I guess, the scope of these calculations is for me personally on my road and during the time I leave for school. So that's why I only collected that small amount of data. You could probably do this for a longer amount of time, but honestly, I felt like there was a better use of my time than sitting out there and setting up my camera every day. So moving on to the second major assumption was the speed of the cars, assuming that everyone drove past my house as a criminal, just like everyone else in this room is a criminal. They were probably doing about 10 kilometers over the speed limit. So my speed limit is around 40 kilometers an hour. So I set the speed of every car that passed by my house to be 50 kilometers an hour. And then to talk about the lifetime risk of doing this, if I was to repeat this every day I left my house for however many days and years I lived on this road, we'd come to like the total lifetime risk of this. So I set it at I'd cross my road 350 days a year for 60 years, assuming that I started crossing the road at the age of 10 and wouldn't stop crossing the road at 8 a.m. until I was like 70, when I died, pretty much. So hopefully I lived that long, but I'm going to tell you right now from the calculations, it doesn't look that good. So now we know what false pretenses we're operating under, we can start discussing the model. So I developed this model using multiple supercomputers, and what this allows me to do is really simplify some of the calculations. What you guys need to know is that basically my neighbors don't like me, and if you were to ask the version of myself performing the calculations, if everyone on the road would hit me if I was in the road, I would say yes, absolutely. Do I actually believe that? They probably wouldn't, but to simplify the calculations, they definitely would hit me. So we're going to start on this side of the road, and we're going to end on this side of the road. And what I'll do is in the morning I'll cross from my house, cross the road, enter the kill box, and then make it to my truck. But what's important about this model is that if I'm in the box and a car is also in the box, it will actively try to hit me. So that's what I mean by my neighbors are pretty aggressive. So if I'm on this side and a car is coming this way, they will jump the line to hit me. Hopefully your neighbors are nicer, but for the calculations, we're going to stick with this. And it makes it nice just so we can simplify some stuff later. So this is what we're operating under, starting here, finishing here, entering the kill box, and hoping that a car doesn't occupy the kill box at the same time we do. All right, so now that we understand the assumptions and kind of the model I've thought of for this type of experiment, we're going to look at the calculations I did. So taking a look at my board of stickies here, we can see that we start with an assumption of a 4-meter kill box length, 50-kilometer car speed, and 399 cars counted in that hour and 15 minutes. This gives us a total time the road was occupied of about 115 seconds. Now to find the fraction of the road that was occupied, we want to divide the we want to divide the amount the road was occupied by the total experiment time, which gives us about 2.7% of the time the road had a car in it. So multiplying that by how many times this event occurs, which is about 2,100 or 21,000 for me, sorry. So this times 2.7% ends up giving me a total lifetime risk of 566. That is not in percent. That is, if you guys still multiply this by 100 to get the risk in percent. So more useful and more understandable number is how many days before I get hit by a car, which is much shorter and way scarier. It's only 37 days. So I can only walk across my road for 37 days, about maybe a month and 1 week before I'm going to get nailed by a car. All right. After all that, we come to the conclusion that it is not a good idea to cross the road without looking. I wish there was a different answer, and I really wish we could all save that time and save our neck muscles from having to swing both sides, but it's not the case. Those old wives' tales that we've been told as a kid are actually true, and we're gonna have to keep following them if we want to not get hit by a car in like the next 35 days. So I guess, yeah, the message is look both ways before crossing the road. Thank you.